Welcome to Unit Conversions with Exponents. This video is part of a series in Foundations of Engineering by Conceptual Calculus. There are several ways to think about unit conversions. In this video, we follow the method set out in our earlier video, Simple Unit Conversions. If you are not familiar with unit conversions, please watch that video first and then come back to this one. The example of area gives us a clear visual representation of what squaring a unit means. This square is 1 foot long and 1 foot wide. The area is length times width, which is 1 foot multiplied by 1 foot. 1 times 1 gives 1, and foot times foot gives square foot. The area is 1 square foot. Next, we look at a rectangle that is 1 foot wide and 2 feet long. We multiply the length by the width to get 2 square feet. We can see that the area is exactly twice as large as the original square, so 2 square feet makes sense. Now consider a square that is 2 feet long and 2 feet wide. There are two ways of describing this area. 2 feet multiplied by 2 feet can be written as 2 feet squared. That means a square that is 2 feet on each side. If we square the 2 and the unit separately, we get 4 square feet. This corresponds to 4 smaller squares, which are each the size of our original 1 square foot. The terminology here can be confusing. Pay careful attention to the order of the words. This is 2 feet squared, or 4 square feet. This last figure is 4 square feet, but it is not 2 feet squared. It has the same area as the large square, but not the same shape. Next, we look at converting area units. This square is 1 foot wide and 1 foot long, so it could be described as 1 foot squared or 1 square foot. The width of 1 foot could also be written as 12 inches. The length can be written in inches as well. Each of the small boxes is 1 square inch. 1 foot equals 12 inches. If we square both sides of that equation, we get the area of our square in 2 different units. Multiplying out the right side, we can see that 1 square foot is 144 square inches. Note that 1 square foot is not 12 square inches. This corresponds to the diagram where we can see far more than 12 of the small squares. Now we look at some examples. Express an area of 3 square feet in square inches. This works like the simple unit conversions that we did in a previous video. First, we need an equation relating feet to inches. This gives us 2 conversion factors. We need to choose the correct one. The feet that we want to cancel out are in the numerator, so we need the conversion factor that has feet in the denominator. This still doesn't allow us to cancel out the feet, because we have square feet in the numerator, and the feet in the denominator are not squared. Remember that each conversion factor is equal to 1. And 1 squared is still 1, so we can square the conversion factor without changing its value. To square the conversion factor, we apply the square to every number and unit in the conversion factor. Now we have square feet in both numerator and denominator, so the square feet cancel, and we are left with square inches. When you multiply out the numbers, do not forget the square on the 12. This tells us that 3 square feet equals 432 square inches. Cubing units works the same way. We want to express a volume of 4 cubic meters in cubic feet. We start with an equation relating meters to feet, which gives us 2 conversion factors. We write our 4 meters over 1 and select the appropriate conversion factor. We have meters in the numerator, so we need a conversion factor with meters in the denominator. This still doesn't allow us to cancel out the meters, because we have cubic meters in the numerator, and the meters in the denominator are not cubed. Because every conversion factor is equal to 1, we can cube the conversion factor and it still equals 1. Cubing the conversion factor means cubing every number and unit in the conversion factor. Now the cubic meters cancel and we are left with cubic feet. When you multiply out the numbers, do not forget the third power on the 3.281. This tells us that 4 cubic meters equals 141.3 cubic feet. The next example is an acceleration of 10 feet per second squared that we want to express in miles per minute squared. To convert the length units, we need an equation relating feet to miles. To convert the time units, we need an equation relating seconds to minutes. Each equation gives us two conversion factors. The speed of 10 feet per second squared has feet in the numerator, so we use the conversion factor that has feet in the denominator. This conversion factor does not need an exponent. The feet cancel, leaving miles. Because the original quantity has seconds in the denominator, we need a conversion factor that has seconds in the numerator. This does not allow us to cancel the seconds yet, because the denominator seconds are squared and the numerator seconds are not. We square the conversion factor, which means squaring each number and unit in the conversion factor. This cancels the seconds squared and leaves minutes squared in the denominator. When calculating the result, do not forget to square the 60. 10 feet per second squared is equal to 6.818 miles per minute squared. Finally, we consider an example that uses an SI prefix. We want the area of a rectangle that is 492 centimeters wide and 738 centimeters long. Because both factors have units of centimeters, the product is in centimeters squared. This is customarily written without parentheses. With or without parentheses, the square applies to the c as well as to the m. The prefix c represents 10 to the power negative 2. Because the c is squared, we square 10 to the power negative 2, which gives 10 to the power negative 4. 1 square centimeter equals 10 to the negative 4 square meters, not 10 to the negative 2 square meters. Let's convert this area to square meters. As usual, we start with an equation relating meters to centimeters. This gives two conversion factors. We want to cancel centimeters out of the numerator, so we choose the conversion factor with centimeters in the denominator. We can't cancel the centimeters yet because they are squared in the numerator but not in the denominator. Squaring the conversion factor solves this problem. Remember to square every number and unit in the conversion factor. Now we can cancel the square centimeters and find that our area is a little more than 36 square meters. I hope this has been helpful. Conceptual Calculus thanks VIVA, Virginia's Academic Library Consortium, and New River Community College for their generous support.